So let's see, to start with on this, what we're going to do, a lot of what we do today is hopefully stuff that you've had in your background. So we're just going to you're going to fill in some of the key things. One of the reasons I like to do notes this way is because you don't have to write as much. You got all your definitions and diagrams and graphs and stuff like that, all right? So let me just kind of go over some of these definitions. A relation just means that you have a set of ordered pairs. Ordered pairs are points, okay? For our purposes, we got this. So these would be two examples of relations. You just have a set of points, okay, like that. Now, a relation can be a function. A function is a special relation. So we're going to talk about functions all semester, so we want to be sure that we're clear on what a function is. That's the first thing, all right? So here's what the way our textbook does this. Our textbook says if you have two sets, x and y are sets, okay, a function is a special relation such that everything from set x, it associates with exactly one element of y, okay? So let me explain what this is. It's actually real easy. If you look at this particular diagram right here, this is what a function looks like. This is a set of numbers. That's a set of numbers. That one, the x's we call the domain, the y's we call the range. So what happens is you try to see this. Does every x have one y? In this case, it does. That goes one arrow, and so forth. That's what a function looks like. This one is the same way. It's okay if the arrows, intersect and stuff. The -2 goes to one thing. Everything goes to one way, okay? Now, what's wrong with that? That's not a function. What makes that not a function? Like that, right? You have a x that goes in two different directions. So it's not a function for that reason. So functions are real simple, okay? So what you would have on this, you just want to fill out the key things on this one. This one is a function, we said. The second one, also, that's a function. And then the third one is not a function because of that situation, okay? All right, so I'm going to have you do these next four problems, and I'm going to go ahead, let's do this first one together here, and just kind of see what this one is. And then I'll have you fill out the rest, just give you a few minutes to do that. Okay, what do you guys think on this one? Is that a function? Yeah, every x has one y. All these guys like Kathy. Okay, that's okay. As long as every x has one y, then we're good. That's a function, okay? So that would be a yes. Okay, so every x has one y. It is a function. Okay, the domain. What did I say domain was? Just all the x values, okay? And they can be names or whatever. So that would just be Ken, and it would be Carl, and it would be Lewis. Okay, and you represent a domain. Those are set braces that you see me using. So you write it in a set brace like that. The range is whatever the y values are like that. So you just write that out. Okay, so a real simple thing to start with. Go ahead and on your handout do number 2, 3, and 4 and see if you can get those figured out okay. All right, and I'll give you just a couple of minutes to get that done. It shouldn't take you too long. And everything we kind of talk about in this class is going to revolve around functions mostly. So it's real important. When you take calculus, you're going to be dealing with functions also. Kind of what we got on this then. So how about number 2? What'd you get? Is it a function? Yes or no? No. Okay, Jerry's a bad boy. Okay? He's got 3 girlfriends. So that's going, that violates the function thing. That's not a function. To be a 2-timing man's not a function. So does each x have one y? No. It is a function. Okay, and then the domain would just be Jerry and so forth. Okay, and then the range, I'm just going to use the first letter, A, B, J. Okay, that's good enough for the purposes of what we're doing. Okay. All right, what'd you come up with on this one? That one has a backwards parenthesis I see there. So is that a function? Yes or no? What'd you get? Yeah, okay, so every x has one y. Okay, the value 1 just has a 3. See, all of these x values are different. Okay, so every x just has one y. So that's yes, that means it's a function. And then the domain, you just write in set builder, you just say 1, 2, 3, 4. It's all the x values. The range would be just 3. okay? You don't have to write 3, 3, 3, 3. You just write 3, okay? How about the number 4? Yes or no? That's a no, okay? What made this not a function? These 2 points right here. Same x, different y, okay? So it's not a function, okay? All right, so that one violates that condition. It's not a function. Now, really on this, you don't have to put the domain and range because if it's not a function, but we're mainly concerned about what the domain and range is when it's a function. But it's not wrong to do that, but the domain would just be 2, -3, 4. It doesn't matter what order you put those in. Then the range would be 6, 9, 10, like that. All right, so that's it. All right, does everybody understand what a function is? At this level, at least. All right? Okay, very good. Next thing, this is something that sometimes students have a little trouble with, is if I give you an equation, you want to know if it's a function or not. And it's always the same. If I give you an equation, you ask this question, just like you did on the last problems. Does each x give exactly 1 y? Now, most of the time you do this in your head. There's really not much to show on your paper unless you have a certain circumstance. So here's the way I look at this. If I plugged in any number in for x, what would happen? If I take a number plus 1, I get 1 answer, right? And then what happens if I take the square root of a number? How many answers do you get? You get 1. So no matter what you plug in for x, you'll get 1 answer. However, let me ask you this question just from your background. Would it be okay if x is -1 on this problem? -1 plus 1, 0, right? What's the square root of 0? So it's okay. What if x was -2? Is that okay? Yeah. -2 plus 1 is -1. What's the square root of -1? It's an imaginary number, okay? But once you have, if x is anything bigger than -1, you're going to get 1 answer. So what you do, and you really do that in your head, you just have to reason that out, is the idea is every x does give 1 y, so it is a function, okay? There's never an x that you plug in and it'll give you 2 answers. Does that make sense? Okay? All right? Next one, do this in your head too, okay? If you pick a number and subtract 4, you get 1 answer, right? How about if you do the absolute value of a number? How many answers do you get? You get 1, okay? So it's the same thing. So the idea is, in your head, you're just reasoning out that, yeah, okay, I get 1 answer, therefore it's a function, okay? Now, we get down to this C. Now, what you do on this one is a little harder to do this one in your head. So what I'm going to do is I'm going to pick a value for x, okay, and I'm going to make it real simple. I'm just going to say, let's let x be 0. It's up to you what you pick. Then if you plug it in, you would have y squared plus 0 squared equals 4. And then from here, you would have y squared equals 4. All right, background issue. When you solve this equation, how many answers does this equation have? How many numbers can you square that will give you 4? There's 2, right? What are those 2 in your head? 2 squared and what else? -2 squared. Okay, that is not a function for that reason. Now, what you've learned how to do in the past is take a square root of both sides, and you've learned when you do that you get 2 answers. Okay, when you do a square root of both sides. So that's a no for that reason. Now, that's one way to figure that out. An alternative way to figuring this out is like this. Okay, a good rule of thumb, if it's not solved for y, a lot of times it's a good idea to solve it for y. So if I solved this for y, I would just end up with 4 minus x squared. I'd subtract the x squared from both sides. Then if I did the square root, I would get y equals plus or minus square root of 4 minus x squared. And what makes it not a function is that plus or minus. Does that make sense to everybody? Okay, so that's not a function. We don't even need to look at the graph. Okay? All right, the next one. Let's do the same thing. Again, just choose something for x. That's kind of a good way to start. Choose something for x and just whatever. Now, you got to be careful about what you choose on this, too. If I chose 1, it probably wouldn't be so good. Let's choose 2. So we have 2 is equal to absolute value of y plus 1. Okay, like that. Okay, what I could do is I could subtract 1 from both sides. You can do that in your head. So you would get 1 equals absolute value of y. All right. Now the question is, how many answers in your head does that equation have? 1 or 2? What are the numbers that you take an absolute value of that gives you positive 1? 1 and what? Negative 1. Right. Okay, so this has 2 answers. Okay, so the thing is, y would either be negative 1 or it would be 1. The absolute value of a negative is positive and the absolute value of a positive is positive. So that would not be a function. So see, again, on these ones that are a little harder, just pick a number for x, and if you ever find 2 y's for that x, then it's not a function. All you got to do is find 1. We call that a counterexample when we're trying to find something that shows it's not a function. All right, you guys follow what I'm doing? This is one of the harder things in this section sometimes students have. That's just a real logical way to run through them. Okay, so go ahead and do the next 2. I'll give you a few minutes to just think through the next 2. You could do it in your head if you really know the math behind this. It's not a bad idea, particularly on that part B, to choose a few numbers for x and just see what happens. Choose a number and see if you find 2 y's. Okay, so I'll give you a couple minutes to run through that. Just a minute. Okay. All right, so what would happen if you take a third root of a number? How many answers do you get? You get 1, right? Is it okay to take the third root of a negative number? Yeah, okay. That's something you might write down if you need to. Like if you do the third root of negative 8, that's negative 2. The reason is because negative 2 multiplied out 3 times gives you negative 8. The point is, no matter what you plug in for x, you're going to get 1 answer. So that's a function for that reason. Okay? All right, now the next one. Now there's a couple of ways that you can go about doing this. What I'm going to do on this is just pick some number for x. Okay, and try to keep it simple if you can. What I'm going to choose is I'm going to choose x equals 2 and just see what happens. This is one way to figure this out. So if you did this, you would have 2 squared over 4 plus y squared over 9 equals 1. Okay? If you do this, this would be 4 over 4. That would be 1. Oh, that was a bad choice on my part. Now, let me explain why that's a bad choice. Okay? Well, if I went through and subtracted 1 from both sides, that would cross out, and I would get this. Well, that equation has one answer. Y has to be 0. That's a bad choice. So what I probably should have done, and you want to be cautious about that, is let's try a different one. Let's try x equals 4. Okay? And then if you do this, what we're going to have is 4 to the second over 4 plus y to the second over 9 equals 1. And then if you do this, see in your head, that would be 16 over 4, so that's 4, plus y squared over 9 equals 1. Another bad choice, okay? I need to think about this a little bit better. I'm going to show you another alternative way to do this. If I subtracted 4 from both sides, I would end up getting y squared over 9 equals negative 3. Well, you would have to take a square root of both sides, and you can't take a square root of a negative number. So that's kind of a bad choice on that. So what you will run into sometimes on these problems is you might pick several choices, and it may not be getting you anywhere. So another thing that you might want to do on this problem is this. We're going to solve this equation for y, and I'll show you what happens. Okay? So you don't have to really, you can do this in a lot of different ways. All I'm going to do is just do this. I'm just going to move that over to this side, so I'll end up getting y squared over 9 is equal to 1 minus x squared over 4 like this. Okay? Now there's other ways to solve this, and you don't even have to finish it. If you went through and took the square root of both sides, you would have a plus or minus there, right? Okay, and then what would happen is this would be y over 3. You know, square root of y squared is y, and so forth. Well, here's the deal. That's all you got to do. You don't have to do anything else. So the idea would be, if you plugged in a value for x, you would get how many answers? you get 2, so it's not a function. Now, a lot of students, in time, when you see a y squared in your problem, that's a good indication that if you solved it for y, you would end up with a plus or minus square root. So you could reason that out in your head just by seeing that y squared. Does that make any sense what I did on that? Okay. Now that one, you know, I tried to just pick values and I wasn't getting answers. So you can't just try one thing. You got to find something that provides more than one x. So if you solve that for y, that's the reason it's not a function. Okay. Now you can solve that equation for y in a lot of different ways. That's the way I did that's not even the best way, so that would not be a function. Does that make sense? Is there any question about that? Okay, so when you're doing these problems, you can try to do them in your head. If not, a good thing to do is solve for y. Okay, if your equation's not solved for y, then try to do that, and then that'll help you. Okay, all right, any questions? I want to get this finished up. The next thing, the third kind of thing we're going to look at on here is just function notation evaluating functions. All right, so you took this kind of stuff in high school, you've learned about function notation. So if I give you a function like I do on this example, I'm going to just do these together right here. All you're doing when it says f of -1, it just means where you see an x, you just plug in -1 and evaluate it. So it's arithmetic. So you want to know that, the notation and the language of that. So what we would do, let's go ahead and just put this together here. So we have f of -1 and then plug this in. Now you have a negative. Now what I always tell students to do is use like parentheses where that x is so that you notate that correctly like that. And then I'll just drop in the -1. All right, then it's order of operations. You need to know order of operations. So what you have to do is you have to do this like this. You have to do that exponent. That's the first thing that you do. Now that negative comes down, and then if you take -1 to the second, that becomes 1. Okay, but then it's going to go back to a -1. And then you want to do this. You want to do the multiplication. So a positive times a negative is a negative, so that's -2, -5, and then you're just adding negatives really. So if you count that up, that's 5, 6, 7, 8, so that's -8. So that's evaluating a function. One of the things you want to do is you want to do basic arithmetic without your calculator. I see students all the time to get their calculator out for everything they do. You want to be able to do basic stuff this way. All right? All right, next one. Okay, I'll give you this function. Now, there's a mistake on there. That should say g of x. It's got to match with that. So the function I'm giving you is g of x. So again, you're just going to plug in 1/2. So when we do g of 1/2, it goes like this. Okay, I'm just going to put like a parenthesis where I see an x. That's a good way to learn to represent this so that you're writing this out kind of neatly. And then we'll just plug in the 1/2 like that then. Okay, just plug it in and then you do your arithmetic. When you're dealing with a fraction, what you want to do is just work out the numerator and denominator. So the numerator will have to get a common denominator of that one you can do in your head. Now when you have 2 times 1/2, the 2's cross out. So 1/2 of 2 is 1, so that's 1 minus 1 like that. Okay? Now I'm not even going to bother working out the numerator because the denominator is 0. What does that tell you from your past? It's undefined. Okay? You can't divide by 0, so that one would be undefined. Okay? If you got a 0 denominator, you're done. Okay, you don't have to do anything else. Okay, everybody with me there? Okay, all right. And this next one, we're going to do f of -3. Okay, so I plug this in. I got 1 minus, and then I've got, just again, replace x with -3. So you'll have -3 plus 2 to the second. And then we'll just work out the arithmetic on that. Okay, so that's going to be 1 minus 1 over, that looks like -1 to the second. Okay, when you do what's inside the parentheses. So that's 1 minus 1 over 1 when you square the negative. So that's 1 minus 1, so that's 0. Okay, so that's evaluating a function. Now you do evaluating a function all the time in math and calculus. It's just fundamental stuff that you want to know how to do. It's mostly arithmetic. Occasionally you will get that 0 denominator, so in that case that's undefined. Okay? Okay. the fourth thing I want to go through here is domain, finding a domain of a function, and kind of talking about what that is. Now, we're only going to look at certain functions, kind of limit what we're going to do in this class. So first of all, some things that you might want to brush up on if you need to is a linear function. Students usually remember this. That's y equals mx plus b, or f of x equals mx plus b. And m and n are just constants on that. So that's a linear function. That's what that looks like. So an example might be something like f of x equals 1/2 x minus 1. Now, what does the graph of that look like? That's a line. Okay, you want to know that's a line. And what will happen is x can be anything. So that x right there can be any real number. All right, so the domain would just be all real numbers for that reason. So you can take any number and multiply it by something and add it to a number and get one answer. So it's a function, okay? A quadratic function looks like this, okay? That's ax squared plus bx plus c. So you've learned in the past how to use the quadratic formula and so forth. Same thing. And what you want to think about is domain. If you plug anything in for x and square it, you get one answer, right? You plug anything in and multiply it by a number, you get one answer. That's why it's a function, but x can be anything. There's no number that you cannot square, and there's no number that you can't multiply by something. Okay, so that domain's all real numbers. Okay, a polynomial function just means that you have sums and differences, whole number powers of x. That's the easiest way to define it without writing a bunch of mathematical symbols out. So what you have in a polynomial is your x's they can have whole number powers, and then you just have sums and differences. Okay, these are two examples of polynomials like that. What you want to know, though, is the domain is all real numbers. If you had a third power, there's no number that you cannot cube. Okay, there's no number that you can think of that you can't raise to the fifth power. So every one of these functions, the domain's all real numbers. So when you spot that you have a linear, a quadratic, or a polynomial, you'll automatically know what the domain is, and you don't worry about it, okay? So I want to talk about two things. Set builder notation goes like this. If I want you to write an interval in set builder, you put a set brace. If you're asked for the domain, you're asking for what x is. So you put an x, you put a bar, and then on this you can just say x is a real number. There's several ways you can write this, but that would be one way to write that like that. But set builder, you have two set braces, x, and then a bar. That bar means such that. So you read this as set of x such that x is whatever condition like that. Now, if you want to do it this way, a lot of you have seen this before. You can just say set of x. X is a element of the real number system. That's worth writing down. So if you want to do a abbreviation, that just means it's an element of the set. And that R with a double bar is just the symbol that we use for real numbers. So you can either write it out or you can write it that way. You'll see me use that notation most of the time in this class. Now, interval notation, okay, if it's everything, then you say negative infinity to infinity. That's the simplest way. If it's all real numbers, it's just everything on a number line. So it's like that. So is everybody clear what I mean by a polynomial, a linear function, and all that stuff? So when you see it, you automatically know what the domain is. The domain's everything. And if you don't remember that, you can figure it out, okay? You just think about it. Okay, let's look at a square root function now. So we're going to look at the next thing is a square root. So the thing is, if you have a square root, you can do the square root of 0. That's okay. You can do the square root of a positive number. That just gives you a positive. What can you not do? You can't do a square root of a negative. Okay, so what happens is if you got a square root function, you need to determine figure out what under the radical, what makes the number under the radical, the expression, positive. So what you typically do to find the domain is you just set the expression under the radical greater than or equal to 0. Equal to 0 because square root of 0 is okay. Greater than 0 because it's okay to do a square root of a positive number. Okay. So on this next page, these things you can do in your head, but usually you have to do a little calculation. So here's what you do. If you have a square root function, look at what's under the radical and do this. Set it greater than or equal to 0. Now this next problem I'm going to do in a minute is a little bit different. Then you solve that inequality, because what that's going to tell you is what values of x make that expression positive. Does that make sense to everybody why I'm doing that? Okay, you can only take a square root of positive or 0. Now you solve the inequality. Okay, so you can add 6 to both sides, or you can move the 6 to the other side, so you get 2x greater than or equal to 6, divide by 2, kind of a standard equation, inequality, so that's x is greater than or equal to 3. Okay, so what happens, now check this out in your head. You want to learn to do stuff in math in your head. Check. If you plugged 3 in, what do you get? 2 times 3 is 6. 6 minus 6 is 0. Is that okay? Square root of 0. Yeah. Okay, how about 4? 4 is bigger than 3. 2 times 4 is 8. 8 minus 6 is 2. Square root of 2, is that okay? Yeah. Okay, try 2. 2 doesn't work. 2 times 2 is 4. 4 minus 6 is negative 2. What's the deal with square root of negative 2? It's an imaginary number. So you can tell you're right. Okay, if you plug in a few numbers in that interval, you can tell that it works. Okay, so the way you would write this is like this. You would say set of all x such that x is greater than or equal to 3. Okay, interval notation, this is stuff that you need to know from your background. You have a bracket, 3, comma, infinity like that. Okay, if you need to brush up on interval notation, and in the modern world, what do you do if you don't remember something? You go to Google, right? And you can find everything. You can find videos. If you don't know interval notation, just go Google it, and you can find everything you need to know. Some of you may need to do that. Okay, does that make sense to what I did on that to everybody? Is any questions? Okay. Now watch the next. Go ahead.
Just making sure that I have the right words for it, because I followed math, but so you basically just set the entire equation to 0 and then solve.
Greater than or equal to 0. Because what's under the radical must be greater than or equal to 0. It's hard to do a lot of these problems in your head, but that's what you will always do. And then the other thing I was trying to show you is, if you plug 3 in, you get a good answer. If you plug any number in bigger than 3, you get a good answer. Otherwise, you don't. Does that make sense to everybody?
Okay. It goes back to that even and odd root thing, right?
Say that again?
That would just be for a square root.
Exactly. It's only a square root. Okay. Now, if you had an even root, it'd be the same way, like a fourth or a sixth, not a cube root or odd roots. Because see, in an odd root, you can have a negative number under the roots of it. Okay. Okay. Now watch this one careful. There's something slightly different about this one. All right. You do have a radical. All right. So this is what you do, just like the last problem. What I said is you take what's under the radical and you set it greater than or equal to 0. There's something wrong about this on this problem. Is it okay for this to be 0 in this problem? No. How come? Well, it's in the denominator, right? Okay. So it is not okay to be 0. If your radical's in the denominator, and don't do that, just do greater than. Does that make sense? You cannot have 0 denominator, so what you want to do is you want to just set it like this, okay? Right? And then you can solve this. You can do this in your head. You can add 1 to both sides, so you get x, whoops, I'm doing this. X greater than 1 is the answer, okay? So you just write this like this. Set builder, put a set, x bar, x greater than 1 like that. That gives you your answer. Interval notation, what does that mean? 1 and forever. So what do you say? 1 comma infinity. So if you do interval notation, you say 1 comma infinity like that. Okay, I won't go through interval notation in this class. I don't have time to do that, but you can come in and see me if you need a little bit of help on that. All right, does that make sense to everybody? Okay, now the way that you get this totally crystallized in your mind is if you plug 1 in, it doesn't work. That's why we have a parenthesis. That excludes the 1. Okay, and then any number bigger than 1, you'll be okay with your radical. You'll have a positive number to the square root. That's what you're trying to verify. Is everybody with me there? Okay. All right. Okay. Now, the third case, and we're only going to do 3 cases on this. It's just kind of the things that are common that that pop up. So we have what we call a rational function. Rational functions are just ratios of polynomials. So a rational function, you just have a polynomial in the numerator and one in the denominator. And more technically, in a polynomial or in a rational function, this can't be a constant. You couldn't have a denominator just of 7. The denominator's got to have an x in it. That's a little detail of a rational function. Well, so when you see a rational function, it's all about the denominator. What's the one thing the denominator can't be? 0, exactly. So you can do it in your head sometimes you can't. So what you would do in this example is you just look at the denominator. You don't really worry about the numerator. So you just say 2x plus 7 is equal to 0, then you solve that equation. Okay, so again, you can subtract 7 from both sides, just kind of move and rearrange. So you got that. You want to make sure you know how to solve basic equations in this class, so you get this. All right. Now the way you write the domain on this is you say set of x, and then you just say x cannot be equal to, so it's not equal to negative 7 over 2. It's everything else. So really, technically, x can be everything except that. If it's negative 7/2, you got a 0 denominator. So that's the way you write that, is you just say that. That's good enough. Does that make sense? Right? Because it can be anything else. It's not like inequality like the square root was. Now, interval notation, you got to go like this. There's only one thing on the number line it can't be. So interval notation, you say negative infinity to negative 7/2, and you put a parenthesis. That parenthesis excludes the negative 7/2. Then we use a union symbol, and then you say negative 7/2, and then forever, okay? So that's set builder. That's how you do that in interval notation, all right? Any questions on that? Remember, intervals are on that is just always name them left or right, okay? Okay, if you look at this next example on here, in your head, look at the denominator and only look at the denominator. Can you think of any number that you plug in for x that would cause that denominator 0? Just in your head. What do you think? What happens if you square a number? You get a positive, or you get 0. Well, if you get 0 and add 1 to it, you got 1. You're never going to get 0 on that. Okay? Anytime you square a number and add 1, you get a positive result. Does that make sense? So actually, you could do this in your head or I'll show you what else you could do. So what you could do is you could go x squared plus 1 equals 0, just like we did the last problem. Then you could subtract 1 from both sides, like that, then do the square root of both sides. Well, what's the deal? That's imaginary, and we're not looking at imaginary numbers. So that means that the domain is all real numbers. So we would say set of x, we would say x is a real number. So that goes like that, okay? And then interval notation, if it's all real numbers, is negative infinity to infinity like that. Now say, again, a problem like that you can do in your head, or you can always do this. That's what you always do, is just set the denominator equals 0. Does that make sense to everybody okay? All right, any questions? Okay. All right. So let's go ahead and I want you to take a few minutes to run through these and see what you get. I'll walk around. I want to kind of see if everybody's with me here and doing what they're supposed to do. I'll give you a little bit more time to do these because there's a little bit more that you need to consider as you're doing these problems. Okay, so first of all, on number 1, tell me what kind of function this is. That's linear. Okay, its graph is a line. Okay, so that means the domain's all real numbers. Now think of it this way. I mean, x could be anything. You can take any number and multiply it by 2, right? That's the point. You can't think of a number that can't be doubled, right? So anything works. So with this one, you just write set of x, then you can do x as a real number, like I taught you to do. That's an easy way. Interval notation, negative infinity to infinity, like that, okay? The next one is a radical square root function. So what kind of number has to be under the square root of positive or 0, right? You can do it in your head, but it's easier if you just write down 10 minus 5x is greater than or equal to 0, okay? Now, I threw this problem at you because I wanted to kind of see how many people remembered how to do this. Now, this one you can subtract 10 from both sides. You don't have to show that step. You would just end up with negative 5x greater than or equal to negative 10. Okay, now let's see how many people remember this. What you have to do now is you have to divide both sides by a negative number. What happens on an inequality if you divide by a negative? Switch the sign, okay? That's something you would learn in your past in an algebra class. I can give you a very fast explanation of why that is. So you would actually get x less than or equal to, and then negative 10 divided by negative 5 is positive 2. If you didn't switch the symbol, that's something you want to make a note of. I'll show you why that works in just a minute. So you would say set builder, set of x, such that x is less than or equal to 2. Okay? The way you write this as an interval is this is just saying you're to the left of 2. So you'd write that as negative infinity 2 with a bracket on it like that. Okay? How many people got it right? I'm just curious. Okay, I bet a lot of you did not remember a thing about that change in the sign. Let me explain why. I can write this down if you want to, but you don't have to. Okay, everybody would agree 4 is less than 8, correct? Yeah? Okay, well, look what happens if I divide both sides by a negative number. I would get negative 2, and I would get negative 4. Okay, well, the thing is, negative 2 is actually bigger than negative 4. So anytime you got an inequality and divide or multiply by a negative, it changes things. All right? So when you're doing an inequality, the only time you're ever going to switch that sign is if you divide or multiply by a negative. Okay? That's something you would have learned somewhere in the past in algebra. So make sure that you're aware of that when that shows up. Okay? All right? And you catch your mistake by checking, by the way. If you plugged in numbers in your answer, and if you forgot to change that sign, you would find out it doesn't work. Okay, what do we call number 3? What kind of function is that if it's got a fraction? That's rational. All right, so what are you looking at? You're looking at what makes the denominator 0. This one is one you can do in your head, or you can just write down x plus 2 is 0, subtract 2 from both sides, you get x is negative 2. All right, now you write this like this. You would say set of x, and then you just say x is not equal to negative 2. You're just telling me that it's everything except what makes that denominator 0. Okay? Interval notation would go like this. You would have to write this as negative infinity to negative 2, and then you would have to go negative 2 to positive infinity. So that's the way that you exclude one number in an interval is like that. All right, does that make sense? Okay. All right, well, let's see. The next one. This one's the one that I didn't do an example like this, but there's two things you have to look at on this problem. First of all, in your head, what would make the denominator 0? In your head. Negative 7, right? Okay. So you have to do two things on this problem. X plus 7 equals 0. That means when x is negative 7, you have a problem. Okay. The other thing you got to consider is this. What kind of number does x minus 5 have to be? It has to be greater than or equal to 0, okay? Anything under the radical, so you would have to solve the inequality like that. Okay, then you could add 5 to both sides. You do it in your head, just move the 5, so you'd have x is greater than or equal to 5. So basically you'd write this kind of like this. You would say set of x, and then you could say x is not equal to hold on. You know something on this one? I'm going to go ahead and write it this way. But let me explain something on this, okay? You could write it that way, but it's not necessary. Does anybody know why it's not necessary for me to write that in my answer? Yeah.
Because it just has to be greater than or equal to 5.
That has to be greater than 5. So we're already greater than 5. It's not really wrong to do that, I guess. It's just unnecessary. So the best way to do that would just be, mark that out because you don't need it, okay? We already got to be bigger than 5, so that just excludes the whole thought about the negative 7, okay? Then interval notation would be bracket 5, infinity like that, okay? That's the one that you got to think a little bit more about. So that's the idea. So you want to make sure that you can recognize the different function, and then the methodology for finding the domain. And if you want to learn it really good, once you get an answer, check it. That's what students don't do in math all the time. Students hardly ever check anything. They just go to the next problem. But that's how you really understand stuff, is you think, okay, x greater than or equal to -5. So if x is 5 or bigger, there's no problem in the numerator. That's all that matters. So you have identified the values of x and what they can be, all right? Okay, so let's finish up with a couple more things on here. Want to get through all of 1.1 today, and then this is kind of where you get into the heavier algebra. So algebra of functions, you can take two functions and you can add, subtract, multiply, or divide. So this is just a little bit of exercise with working with functions. So I'm going to run through a couple of things on this. So I've given you these three functions. This one we're doing f plus g of -3. There's more than one way to do this. I'm just going to do this like this. What you can do is you can do f of -3, then g of -3, and just add them together, okay? And when you're doing f of -3, well, you take the function f, and everywhere you see an x, you just plug in a -3. So you would have -3 squared minus 4 times -3 plus 1. That's how you work out f of -3. Now when you're doing g of -3, okay, well, you plug this in like this. So what that would give you is square root of 3 times -3 minus 1. I like this problem already because I don't have to do anything else. Okay, here's why. If you look at this part right here, what's going to happen with this? You're going to get the square root of -10, right? Is that okay? No, so you don't have to do anything else. The answer to this problem is undefined for that reason. You could go ahead and work it out if you wanted to. I mean, this would just give you 9 plus 12 plus 1, and then you would end up having the square root of -10. But hey, you can't have a square root of a negative number, so that's undefined. Okay, so that you can have situations on these problems where they can be undefined. Okay, all right. The next one, what you're doing is you're subtracting the two functions. So what we'll do on this is you want to write this as we're doing f of x minus g of x. And you want to set it up, and it's just kind of an algebraic simplification problem. So I'm going to take f of x, which is x squared minus 4x plus 1. Then I want to subtract off the g of x, which is square root of 3x minus 1, like that. Now, there's nothing you can do on that problem. There's no like terms or anything. So what I would do on that then is just write the answer like that. There's no other simplification you have, so you would just bring it down. You don't need the parentheses really on that. So we would just have x squared minus 4x plus 1 minus square root of 3x minus 1. So all you're doing is just taking the two functions and subtracting. If you had like terms, then you could go through and do that then. All right, you guys with me so far on what I'm doing? Okay. All right, the next one is like multiplication. Okay, so on multiplication, what we're going to do on this one is just multiply these two functions. Okay, so what we'll do on this is equal to f of x multiplied by g of x. And this will be a lot like the last problem. There really isn't anything you can do. You just represent it this way. So that's going to be x squared minus 4x plus 1, and then times square root of 3x minus 1. There's nothing really to do on that except just write it that way. So you're just writing that as those two functions are being multiplied. So when you multiply functions, you get a new function. That's the idea. Okay? All right, and then the next one, we go like this. You're doing division. So what you would do is g of 1/3 over h of 1/3. Okay, now you can evaluate the functions and get a numerical answer on this. So what I'm going to do is you want to take the function g of x, and everywhere you see a x, you put in a 1/3. So that would be square root of 3 times a third minus 1. Okay, in the bottom, now we're going to work with h of 1/3 like this. So what I would end up having here is I would have 1/3 to the third power plus 1, and then you would work out the arithmetic like that. Okay, let's see. What would happen in the numerator? The 3's would cross out. You would end up with square root of 1 minus 1. That's equal to 0. And then the bottom, okay, here's the thing on this. Who cares what 1/3 to the third plus 1 is? What's the answer to this problem? It's 0. Okay, you don't have to work that out because 0 divided by a non-zero number is always going to give you 0. Okay, so again, this kind of stuff right here, you're just taking two functions and doing the arithmetic, whether it's add, subtract, multiply, or divide. Okay, there's not much to that. Sometimes there'll be more algebra in those expressions. Is everybody with me okay, what I'm doing on that? Okay. I want to do one more thing, and then I want to get through this difference quotient today and make sure I get that done. So this next one right here, go ahead and do this next one yourself. Just take the functions and put that in. Let's just take a minute to see if we all get what we're supposed to on that. Just take g of -1 and then h of -1. See what happens. As we go through things on this first day and the first couple of weeks, I mean, there's a lot of things like solving equations, inequalities, interval notation. That's stuff that I can't go through because I don't have time to do that. So you hopefully get a sense kind of where you are with stuff. Okay? Well, you can get it. I mean, if you've had the background, had this before, if you, like I said, if you had math 10 years ago, it's still in your brain somewhere. You just got to get it back out of there, hopefully. That one guy did great last semester. He was in the service and been out 10 years. He did great. And little things like this, like with arithmetic, order of operations, that's background stuff you just have to know if you're going to be successful in the class. So what did we get for an answer here? Undefined. See, the thing on this is, if you worked out the numerator, you would get -3 minus 1. You would get the square root of -4, which is imaginary, but the denominator is -1 plus 1, so it's 0 anyway. Okay, you can't divide by 0, so that's undefined. If it's undefined, it's easy. You don't have to go through and work it out. Okay, you just find that. Okay, all right? Okay, so that should be some stuff when you're doing your homework on that is not too bad. You're going to do a lot of arithmetic and some basic algebra. So I think I'm going to go ahead and do this last page because I want to get through everything on 1.1 here today and do the difference quotient on here. So those of you who took calculus before did a difference quotient. We don't really talk much yet about what a difference quotient is. We want you to be able to evaluate a difference quotient because it's good algebra practice. And when you take calculus 1, you'll know what that is. It's a real big deal in calculus that, you know, when you're doing derivatives and stuff like that, it has a lot to do with that expression. Okay, watch carefully. If you've never done this before, the first thing that some students have trouble with is setting it up. So this is the way I recommend you do this. On this part A, what I want you to write down is start by just writing this expression down. Okay, that's the difference quotient that you're given. Again, don't worry about what that is. It's just an important function. Okay, now here's the way that I like to see students get this set up. I always tell students when you set up a difference quotient, kind of get it built, get the framework built. Put like a bracket minus bracket over h. Okay? I've been teaching this a long time. This is what I've settled on as the best way to get students solid on this. So here's what you do. It's actually very simple. What goes there is whatever I gave you, f of x. So that f at 5x plus 4, you're going to put in there. Okay, you just do what the difference quotient basically tells you to do then. So you want to put the 5x plus 4 there. Okay, now what goes in the second bracket is f of x plus h. Now all f of x plus h means is it's the same thing, 5x plus 4, but that x gets changed to x plus 4, x plus h. So the first bracket, just do it like this. You have a 5, and instead of putting an x, put x plus h. And then you still have the plus 4. So when you visualize this, sometimes you got to learn when you learn math how to visualize things. This is just what I give you, right? What's the difference between this and this? The x changed into x plus h. Everything else is the same. Does that make sense? That's a good way to start, is put the function, change the x to x plus h. If you do it that way, you'll never go wrong, seriously. Okay? So what we do now is basic algebra. So what we'll do here is you've got a distributive property here. So you're going to have 5 times x is 5x, 5 times h is 5h. So it's 5x plus 5h plus 4. Now when you have a minus sign, what does the minus sign do to an expression? It changes all the signs, right? So you'll have minus 5x minus 4. So you're multiplying everything by -1. And then that's all over h like that. Okay? Numerator, do you see stuff canceling? That'll happen very frequently when you're doing a difference quotient. So that cancels, 4's cancel. You're left with 5h over h. And then the h's divide out. H over h is 1, so you get 5. Okay, how many people said they took calculus in high school? Okay, how many of you that took calculus remember what the derivative of 5x plus 4 is? It's 5, right? So if you took calculus, you know the derivative is 5. That's what we just did. Okay, if you never took calculus, don't worry about that. You'll learn that anyway, so I already knew what the answer to that was going to be. Okay, all right, if you took calculus, I kind of make a connection for you. All right, so let's do this next one, see if we can get these things finished up here. So this time what we're going to do is, again, just build the framework. You got to kind of take up a lot of room on your paper too. So I always tell students, just start this way, bracket minus bracket over h. And then what you want to do is get it set up correctly. And there's a lot of algebra that's involved on that then. Okay, so f of x goes there, don't change it, and just put it like that. Okay, now the first one, what you're going to do in the first bracket is put the function, except what are you going to do in place of x? X plus h, okay? So don't say 2x squared, say 2x plus h squared. Minus 3 times x plus h, and then plus 1 like that. So what you want to see on here is the x's change to x plus h. That's the first thing you got to learn on that, is understand that setup. Does that make sense to everybody? Okay, all right. Now once you get it set up, now you got to crunch it out. So the review that you're going to kind of have in here is, well, you got to collect like terms and stuff like this. So first of all, at the side of my paper, when I do x plus h squared, if you know how to do that in your head, I'm fine with that. I'm not going to do that for today, but I'm just going to FOIL. Okay, so if I multiply that out, I have x times x is x squared, x times h is xh, inner term hx or xh again, and then h times h is h to the second like that. So you want to make sure that you brush up on how to do FOIL. You do it all the time in this class in higher math. So that's what x plus h squared is it's that. Write it out twice, FOIL it. Okay. Now if I go back to my problem, I've got 2, and then the result of x plus h squared is x squared plus 2xh plus h squared, like that, okay? And then distribute the 3, so you'd have minus 3x minus 3h, and then plus 1 like that, okay? Just kind of step by step, kind of putting everything together. What does the minus do to the second thing? It changes all the signs. So that's when you distribute that through, that's going to give minus 2x squared plus 3x minus 1. I'm doing real fundamental algebra that you want to know and review as you need to. So really a couple of more key steps. What I'm going to do here is I'm going to distribute the 2 like that. So I'll have 2x squared, and then 2 times 2xh is 4xh, and then plus 2h squared. Then I've got minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1 all over h. Okay, now everything I did there after I set it up is FOIL and distributive property. That's all I've done is basic algebra stuff. Now what? What do you notice in the numerator? Stuff cancels, okay? It always does on these difference quotients. A whole bunch of stuff will cancel out. So that's going to cancel, that's going to cancel, the 3x's cancel, the 1's cancel. So what you're left with is this stuff right here. And notice everything has an h in it. So you would have 4xh plus 2h to the second minus 3h over h. Okay? Now you got to know how to factor. We're going to do a lot of factoring this semester too. So what you can do now is you can take an h out of that. And if you take that out, we'll have h times 4x plus 2h minus 3 all over h. Okay, factoring's another thing you may have to brush up on. Again, all I did is just pulled an h out and wrote it as a distributive property there. Now what happens? H's cross out, and then you're done. Okay, so your answer is going to be 4x plus 2h minus 3, like that. How does that look to some of you out there? Back from your background. FOIL, distributive property, collecting like terms, factoring. That's what you do in this kind of thing. Now, doing the difference quotients in the first section that we do is probably the hardest thing you learn how to do. But if you get it down, to me, if I can get somebody to do a difference quotient well on any of these type of functions, then you probably have got beginning to get your basic skills underway the way that you need to. Let me just ask a question out of curiosity. Those of you that took calculus in high school, can you tell me what the derivative of that function is?
Wouldn't it be 2x minus 3?
4x minus 3. Yeah, don't worry about how I did that. So if you did the derivative 4x minus 3, well, in calculus, then you let the h go to 0, and then there's your derivative, okay? So, I mean, when you get to calculus, you'll learn what that is and the significance of a derivative and everything, okay? All right, that looks like that's as far as we're going to make it today. We'll wrap this up next time. So be sure you go on Canvas and you know what to do.